Hi again. So the next thing we're gonna discuss during this lecture is the gravity model of trade. Gravity model of trade was created over 60 years ago by a very famous economist, Professor Timbergen. And unlike other trade models that we're going to listen to, this is not a theoretical model that starts with a set of assumptions and then we go to the conclusion. This is more of an empirical model. And what do I mean by that? You will see you will see very soon. Look, the basics of the gravity model of trade takes, of course, its roots in Newtonian law of gravity, and the model is said to be rather empirical, is because it does not put a lot of emphasis on economic explanation, but just describes the general pattern of how countries trade with each other. Okay, so let's go through the step by step by what we have in the model, and then we will explain the rationale behind this model, which is very intuitive. Okay, so look, here we have trade between two countries, I and J. By trade, we mean sum of exports and imports, but we of course remember that imports from country I, when we talk about just two countries, are equal to exports of country J. So here we have bilateral trade. Bilateral trade means the trade just between the two countries. Now, what do we have on the right-hand side of the equation? Well, A is a normalizing constant. It's needed mostly for us to be able to calculate the linear model. We do not put much emphasis on interpretation of that. The important part really is over here. So what do we see over here? We see GDP of country I in real terms and GDP of country J. So we multiply them here. So we obtain here something that we will call real GDP product. So this is a product of GDP of two countries. And this entire product is taken to the power alpha, where we assume alpha to be a positive number, which, as you will see, always happens in practice. As well, similarly, in the denominator of this fraction, we've got geographical distance between the two countries taken to the power of beta, where beta is also assumed to be positive. And look, right away, just from looking at this equation, we can deduce what the model predicts. The bigger is the product of GDPs of two countries. So the bigger are the GDPs of two countries, the higher should be the volume of trade between these two countries. On the other hand, the bigger is the distance between two countries, the smaller should be the volume of trade of these two countries. Now, what is the rationale behind this? It's actually really straightforward. We expect for bigger economies to trade more. And look, it doesn't really matter if we look at the GDP from perspective of production, because the more the country produce, bigger the GDP, the more this country can sell. Now, when we look at GDP from the income side, we see that the bigger the GDP, the higher the income of the domestic residents, the more money they can spend on imported goods. So we predict, based on gravity model of trade, that bigger countries will trade on average more with each other. Now, geographical distance. The bigger the distance between two countries, the higher is the transportation cost. The higher the transportation cost, the lower the profitability of exports and imports. So, in this case, we predict that the bigger the distance between countries, the less they should trade with each other. Okay, now the main advantage of this model is that it's extremely easy to assess it empirically, but maybe not at the first look. You see, we have like some fraction, exponential expressions. This is not what we see in like classical OLS model that we usually start with in econometrics. But as we learned in dynamic economic analysis, the models like this can be transformed very easily using logarithms. And look, if I logarithmize both sides of this equation, I use a couple of simple properties of logarithms, I'm getting this. Logarithm of trade between two countries equals to ln A plus alpha times ln real GDP product minus beta times ln distance. Now, if we want to estimate this equation, what we are missing is, of course, the stochastic component that we put over here. But look, this gravity model of trade is either called a backbone or a workhorse of international trade empirics for a very simple reason. Because look, once we've accounted for sizes of GDP of two countries and distance between them, so for transportation costs, it is really easy for us to examine the impact of other variables without having much to worry about omitted variable bias and a lot of collinearity that those variables would have with these two main forces behind bilateral trade. So look, what we are going to do today is that we're going to first estimate this equation, and then we're going to add here vector x multiplied by, matrix x with data on variables, and with and here we see vector gamma, and we will be adding different factors that might impact trade, but those factors will not be taken like directly from the theories, but we can actually conclude them based on common sense. So I'm gonna use data here that I used in a paper that is soon to be published, I think in Journal of International Studies. I'm actually on Zasoby. You can find the preliminary version of this paper. Why is this important? I will explain a little bit later. But in our dataset, we will have 26 European Union countries, without Croatia and Malta, for which I couldn't get all the data needed. We are going to examine bilateral trade. So trade flows between any pairs of countries. So if we have 26 countries, we can have actually 325 country pairs. We actually can use a simple formula for pairs where n is the number of countries and number of unique pairs, where it doesn't matter if you have Germany, Poland, Germany, like we treat it as one pair. Then the formula is simply n times n minus 1 divided by 2, which gives us 325 pairs. Now, the time coverage is 1995-2015 period, but as we will learn a little bit later, the part of international trade that actually interests us is the long run part. So what we use here are the period averages, and consequently we are using cross-sectional data, which is the easiest to handle econometrically. Okay, now what variables are we going to use? Okay, so here you have list. First, this is LN trade. Look, it's really easy to find data on trade. We discussed where you can find it. Taking natural logarithm of trade also not a problematic thing. Second, ln real GDP product and ln the geo. So we've got natural logarithm of real GDP product and natural logarithm of geographical distance. Now look, again, one more thing should drop into your mind. From dynamic economic analysis. Look, in this model, what we have is ln trade and ln real GDP product, ln geographical distance. Look, if I'm going to take this equation and partially differentiate it with respect to ln real GDP product, I'm going to get alpha. But look, what we learned during dynamic economic analysis, that the derivative of logarithms is equal to elasticities. So this gives us beautiful and very clean interpretation of this model. Because look, alpha is partial derivative with respect to GDP product, ln GDP product, and beta with respect to ln distance. So alpha measures elasticity. So we interpret it as if real GDP product of two countries increases by 1%, then trade between these two countries increases by, on average, by alpha percent. And the same thing here is with beta. Remember, we have minus in front of beta, which was explained why previously. And look, this tells us that if distance between the two countries increases by 1%, on average, trade between countries decreases by beta percent. Of course, depending on value of the form of the variable, we will have slightly different interpretations on each component of the parameter vector gamma, but we will get to it a little bit later. Okay. So, the next thing we should take into consideration are tariffs. It's really hard to get data on tariffs. It's very problematic, but there's a way out of it. Look, what I did is that I used the fact that in European Union we don't have tariffs. So, EU variable is a variable that actually measures the average number of years two countries spent in the European Union between 1995 and 2015. So technically speaking, it takes values from 0 to 1. Well, not this in this theoretically, because at some point in the sample, all of the countries were in the European Union, so we do not have zeros here. Then we another thing that can impact trade, which is very understandable, is exchange rate volatility. And actually, I've been using here two proxies for exchange rate volatility. The one that you see at the bottom is just calculated. So I've taken bilateral exchange rate between two countries. I calculated its variance. I divided by mean, and we obtain something on something we called coefficient of variation. It tells you by how many percent on average the exchange rate deviates from its average value. And now the second one is monetary union membership. So average number of years both countries spend in the Eurozone. And of course we can expect that all those three variables will be those two variables and those two will be correlated. But of course, we should remember that having common currency makes it makes easier to trade. You don't need to exchange currency, and you don't need to worry about the changes in exchange rate, which reduces uncertainty. Another two very commonly used in literature is language, common language dummy. Some countries in the European Union share at least one official common language, official language, and the border dummy. Like generally, it's expected that of course, when countries have common border, they naturally trade more. They have more cultural ties, and they well more established trade channels. Okay, so in the next part, we are going to estimate the model. But before we do so, I just wanted to tell you a little bit more about the dataset. Look, I actually created a dataset with 72 potential factors that could influence bilateral trade. The link to the dataset, which I recommend you to use either to check your own, let's just say, hints or your suppositions about what could determine the trade. And actually, it will give you a lot of opportunity to check which factors actually influence bilateral trade flows and which are not. So look, in the description, I will provide you with the link to the dataset. Please download it and try to reproduce what we've done, and then try to extend the model a little bit. And of course, in the sub you will have preliminary version of the paper. In this preliminary version of the paper, you've got an annex in which I explain in detail all the variables in the dataset. Okay, so having this done, let's move to model estimation. Okay, so look, the file I'm using, it's called lntrade. Now, I'm gonna show you first how to estimate the model in Eviews, because it's very easy. You can download Eviews student version for free. Even I use it. It's very comprehensive, so there's nothing to be so you don't need to worry about using it. Okay, so we open foreign file, because this is an Excel file. I should have it in on desktop, and it's here, lntrade. Okay, then look, all you need to do is to click next, 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 finish. The data here is unstructured, which means it's cross-sectional. Okay. Now, let's estimate the model, in the simplest way. So we go to quick, estimate equation, and we start. So our dependent variable is ln trade. Then we add constant, ln real GDP prod, and ln DGO, which is geographical distance, and enter. And look, it's already done. This is our let me increase the size of the window a little bit. I don't think it helped much, but I hope you can see everything. Look, again, this is LNA. We are not interpreting this. It's not important to us. Now, what is important to us are what we got over here. And look, how do we read this? Coefficient, so value of alpha here, value of beta here, of course with the minus, we expected that. Standard error, so by how much on average we are mistaking when we use coefficient for prediction. Here we have t statistic, so we divide coefficient by standard error, we get t statistic, and probability, so this is a p-value. Basically, the lower the better, but definitely we want to be below 0.05, and we are in both cases. Okay, so now let's go to interpretations. Look, we see here that if a product of GDPs of two countries increases by 1%, the trade between two countries drops by 0.92 of a percent. And when distance between the countries increases by 1%, the trade between those two countries declines by 1.31 of a percent. Okay, so look, we now know how those factors influence, but how important are they? For that, the best way to go is to just look at R square. And look, R square for this model with just two variables is over 0.9. So with just those two variables, we are able to explain over 90% of variation in trade. This is why this model is so popular, because this model works really, really well. And as you will learn, because you will be doing similar model for your paper, doesn't really matter which set of countries in which year you choose. The model simply works. Okay, so now let's check impact of some other variables. Okay, what can we add here? Well, let's start with European Union membership. Now, we expected that having been in European Union is associated with less tariffs. So it should have positive impact on trade, and this is what we get. Again, variable is significant at any imaginable level, and we see that actually being a member of European Union leads to higher trade flows. But look, actually R squared increased by 0.02, which is not much. But still, we were able to explain trade flows way better. And you can also see that actually point estimates, so coefficients on real GDP prod and ln and distance have dropped, which is of course expected. Okay, now what about monetary union? Again, we get similar result. So having been in monetary union is associated with higher trade. But look here, there's a little trap, because MU and EU, so being in monetary union and in European Union, are highly correlated, right? So let's put those variables together and let's see which one of them performs better. Well, in this case, we see that this is European Union membership. So for now, let's discard monetary union membership in further considerations. Okay, so what else have we had? We remember that European membership in monetary union declined exchange rate volatility. Look, when you sell goods abroad or you buy goods from abroad, you want to be able to make your economic calculations as precisely as possible, but exchange rate changes introduce uncertainty. So we expect that if those changes are smaller, we should have lower business, we should have a higher trade. So now I'm introducing exchange rate variability into the model. And we see this one is statistically significant at 95% level, slightly above 0.1, which is more than acceptable acceptable answer. And we see that this is along the predictions line of even a common reason we see that countries that have higher exchange rate volatility tend to trade less with each other. Okay, and the last two variables we want to examine is common language, which turns out it's not statistically significant, and border, common border. And again, we get a variable that is statistically significant, and along the prediction line of the model, we get that the of common sense is that we get that sharing a common border actually better facilitates trade. And look, one important thing is to mention here is the importance of these variables. Look, having having real GDP product and geographical distance accounted for, let's round it up, 0.9 r square. Adding these three additional variables increased our r squared by 0.25. Not much. And so this is why the gravity model of trade is so important, and it is so important to include those variables in any estimations when you want to examine impact of something on trade. Look, we can check a lot of different things, and this is what I did in a paper that I recommend for you. Then you can see which out of the 71 or 72 variables that I examined actually turned out to be important for international trade. Okay, so basically this is it. This concludes our lecture. Next one, we will go back to the blackboard, and we will learn some classical and more familiar to you economic models. Now, I just wanted to do one more thing, and what I wanted to show, let's just say, interested parties, is that we can also do it in R. R is way more powerful than Eviews. And because of that, I'm sorry, I'm missing one of my files. Oh, gravity model, here it is. Okay, so look, how do we do it? Look, I'm gonna send you this code. I'm just gonna show you what explain to you what does it mean. Non-interested parties, thank you. See you next week. Okay, so first we open our studio and we open the piece of the and we open the file that I'm sending you, the gravity model. First, you need to install, if you do not have package code, open xlsx, I'm sorry, and we can use again the file lnx trade. Of course, remember, you need to use a different path than I did, and remember about the differences. When you use PC and Mac, we use different slashes. In PC, we use different slashes like that. But okay, this is not important here. So this first line of the code loads the package. Second line of the code loads the Excel file. Here, say columns do not have names, rows have names. And look, and basically we're almost done. Look, now you can use row names in your estimations because they can be treated as variables. Okay, so here I'm gonna build an object model 1. So I use the arrow. Here you have lm function, data, in our case I called trade, and then you build the model, ln trade, then you use tilde is this wavy symbol, ln real GDP product, lndg 0, plus you add all the appropriate variables just like we did in Eviews. Now, once we have model 1, we can use function summary to see this model. And of course, look here, what you have are the results, but the results are exactly the same as we obtain in Eviews. But as you will learn later, hopefully R is way easier to handle once you learned. Okay, so this is everything for today. I hope you enjoyed this class and see you next week. Take care. Bye.